right, here's an example using the half angle formulas. So we're giving you the tangent of an angle having the ratio of 4/3, and that this angle falls between 180 degrees and 270 degrees. So that is in quadrant 3. So earlier in our course, we learned that the tangent ratio is the y over the x. So we're given that the tangent of alpha equals 4/3. So the 4 is going to be our y value, and the 3 is going to be our x value. So we're going to go ahead and plot this point. So the point is 3, 4. So when we graph that in quadrant 3, it's actually going to be a -3 and a -4 to be able to go in quadrant 3. So x, y is -3, -4. So we're going to go left 3 and down 4 on the x and y axes. So here's our point, x, y. So this angle might look something like this, starting at standard position, terminal side, and then there's our angle alpha. What we're going to do is create a reference triangle. So we're going to go up on the x-axis and then back together, creating this reference triangle and reference angle. So this is going to be our x distance, y distance, and then r distance. Well, we need to find out what is that r distance. So this is a right triangle, so we can use the Pythagorean theorem. X squared plus y squared equals r squared. We need to find that r value. So we have x, -3, y, -4, and then r squared. So we're going to square those numbers. So -3 times -3 is 9. -4 times -4 is +16. Add those two numbers together, giving you 25, and then square rooting it. In this triangle, you cannot have a radius that is a negative. So you're only going to have +5. So we're going to go up to our triangle and label that distance from the center out to that point being a distance of 5. All right, we're going to go ahead now and find the half angles for the sine, cosine, and tangent. So the formula for the sine is plus or minus the square root of 1 minus the cosine of alpha over 2. Now I'm going to figure out the plus or minus depending on the quadrant. All right, the next formula, the cosine, is plus or minus the square root of 1 plus the cosine of alpha over 2. And then tangent can be used, there's a few different formulas, and I'm going to just use this one here. 1 minus the cosine of alpha over the sine of alpha. So before we use these formulas, we need to find out, using that triangle, what is the sine and cosine? So the sine of that reference triangle is your y over r. So the y was -4, and the r is 5. So that is the sine value for that triangle. The cosine is your x value over your r. So the x was -3 and the radius of 5. So now we're going to substitute these two numbers into the formulas up in part A, B, and C. All right, so let's go to part A. We're going to substitute that negative 3/5 in for the cosine and do it again here and do it again there. So here we go. So we're going to get the square root of 1 minus negative 3/5 over 2. The rest of this problem, you do need to simplify it. And this angle falls in quadrant 3. So we're going to have a negative. So you do need to simplify this, and we worked with some previous problems here of simplifying. So you can look up here, simplifying. We did those in example 5 and this example here. So you do need to simplify that. All right, continuing on, the sine is also a negative because in quadrant 3. Then you go 1 plus, and then negative 3/5 over 2. And again, simplify that fraction. Last one, 1 minus, and you're substituting the negative 3/5 over, and remember the sine down here is negative 4/5. And then again, use your simplification skills on each of those.